Welcome to another Teardown video. This time it's some radio frequency devices I found in a box in the trash can, together with a lot of other funny things. And they were full of all sorts of goopy things, dissolved foam from the box. So they were obviously packed because they had some value to somebody before they threw them out. They look like they are exactly from the same company, just because of the labels and the way that they are made. This one you can picture search, and then you'll see a Japanese page where it is shown. So, and the way that this is manufactured with everything here, I really believe that they also made this filter. And the page says 300 megahertz. So how about we test if this is really true? So you need a reference load, and the best I got is this one. So I'm gonna connect this to the reference load, and then I'm gonna try some different loads. I actually already know which one are good. So that should be fairly easy. So here's how we do this. We take the RF input and connect to the tracking generator, and the RF output and connect to the spectrum analyzer input. And then we hit the tracking generator, enable the output. Oh, in frequency we say start frequency like 10 megahertz, stop 1 gigahertz, so we got plenty. And then tracking generator again, let's give it some more level, because there is a lot of insertion loss, so you need some more level. And then we normalize. Oh, that was wrong. See how stupid I am? Of course you need to connect the reference load. And then we do the normalize, right? So what will happen here is, now it's actually measuring return loss. So when I put on a load, I get this curve for return loss. This is a quite good one. So this should be flat all the way with this one, but it is not. So let's take the marker and then see. So this is 30 dB and even more than 30 dB return loss. So that is really good. And this is 500. Remember, they said 300 in the spec sheet, and that is only here. So you can use this if you want to measure all the way to 30 dB return loss. You can go to 500. But if you can accept 20 dB return loss, which is more than accurate for most things, really. Look at that. This is 880 megahertz. So that is really good. So I think they made something really fantastic in this one. So I can't wait to open it and have a look what they did. So when I'm inspecting this thing, I see the bottom screws there are different type than the top. And this repeats also on the other side. So this reveals this unit was assembled maybe one place in the assembly line where they assembled one half of it, and then it went somewhere else to, place the internal components, and then the other part, and then the rest of the screws. Then you have like maybe different screws in your boxes, and it's only slightly visible. You need to really know what to look for. You can see that they're different. So maybe they didn't realize this little detail. Of course, this reveals also how you need to open this thing. So let's try and do that. So that was all the screws. Look at that. Those are really, really good quality screws. Really, really, I am really impressed. Anyway, I took out all those screws all the way around, so I should be able to... No? Come on, man. Why not? Maybe I should just loosen the other screws a little bit. Maybe that will help. If I only give them a quarter of a turn. So, come on. That is not going to happen. I need to find us, I don't know what. Oh, come on, man. Really? Is that it? Where the heck is everything? Wow, those are really cool. So this is for soldering. Wow, look at that. So obviously I opened the wrong end. But it looks like it's not going to fall apart. I should be able to open it completely. I just realized there is a way that I can assemble this wrong. So I had to write down here what is the input. So now I removed all the screws, so I should be able to maybe push this. Seems a little bit stuck. So what is in this little thing? Whoa, look at that. Isn't that just cute? Wow, that is amazing. So this is what they've done. I'm actually impressed that this works to that high frequencies. How the heck do they have any kinds of impedance under control all the way up here? And this is just that track and that track. This is really, really funny. Yep. I hope you enjoyed this part of the video. It's absolutely nice to see RF equipment done really, really beautiful. All right, let's try and play with the low pass filter. So first we calibrate tracking generator, normalize, and again let's just do 10 megahertz to 1 gigahertz. They say there is a reject 250 megahertz and low pass. Ooh, look at that. So I'll put it here so we can see what we're playing with. Marker. Let's dial this in. Let's maybe go a little bit closer so we can see. This is the rejection. Whoa, look at that. So it's 50 dB. at almost 250 megahertz. I have no idea how old this is and how it's trimmed. So if it rejects 250, maybe they're using it for a frequency under what? Maybe it was made for the radio amateur band. So this is the 145, 6, 7. See, a half a dB of insertion loss. This is what you easily could accept. For normal radio use, you normally say that you can accept a filter of up to maximum 1 dB of insertion loss. So that is 160 megahertz. So this is probably used for the 2 meter band or even lower. Look at that. Insertion loss is just so low. This is really, really impressive. So if you have 30, 40, 50, 100 megahertz, there's just almost no loss at all. But then harmonics that you're generating of 250, that goes away. So of course this filter is made of maybe components with self-resonance. This point reveals some self-resonance is about to happen. And here there's a perfect resonance. That means the filter has no attenuation at 629 megahertz. And then again, we see a few resonances up here. There's one here where it's changing. 829 and again 926, and there's one more here, 943. All right, enough of all this talk. Let's look inside this thing. What is inside? That is what we came for, right? Let's do the teardown. That's a lot of work with all the screws, and again, those screws are exactly the same super duper quality of screws. I mean, this totally proves they come from the same company. So what is inside? Ui, ui, ui. What is that? A lot of funny. So how is that going to work? So there's a trimmer and a parallel resonance. And then some capacitors. Ooh, those are really, really old. But look how close they are to the metal. Look at that. Is that really a good idea? They got to be almost touching. Let's try and pretend this is the metal. So now it's here. Oh yes, it actually, see, this is the, oh, they're almost touching at the end. That is not a good idea. I wonder. Yeah. Well, but this is how it works. We got some capacitors here. And a parallel resonance. So this opens at 250. So this is why we have this huge drop. And of course at DC, the low pass, everything goes straight through the coil. No, it doesn't. Yeah, the coil is, yeah, of course it is, yeah. This is the center pin, right? So it goes to the other output. But it's clearly, this is from the same company. And a tiny little trimmer. Let's see how this performs when it's open. Okay, so this picture looks a lot like the same. Of course, when you get some. Let's see about this 250 megahertz if it's the same place, because they have to trim this when it's open, right? Oh, now it's 241. So this is definitely affected. Maybe it was like this. So one end is mounted, and then you can still access the trimmer. And now see, the frequency is here, 246, and then they know they need to trim it a little bit too low because it will go higher when you put on the metal. Yeah, exactly. So they tried to hit 250 and they just didn't exactly. What if I, yeah, see, if I move this, I can change the behavior a little bit. But that is what was inside those thingies. Thank you for watching. Hope you had fun.